Okay, in this video we're looking at essentially worked examples for the transformations transformation theory stuff we did in the previous video. Now I'm going to be looking at in terms of x today just because that's got the worked examples you're looking at. So it's x squared, log x, and the reciprocal of x. Okay, you can do the exact same things for your y values, and you can even though on each of these I've got them separate because they've got separate numbers. Each of these you can do an x squared, a log y, and a 1 over x all on the same page if you want to. I'll sort of show what that means in a moment. But let's get started on this. So in the first one, it's calculate x squared. You've got your data and you're going to do an x squared transformation. Now let's first have a look at why you're going to do that. Sorry, I had that up for something else before. I'm going to go Control I. I'm going to go Add Data and Stats. And I'm going to go here. I'm going to go. Now I've picked X1 just because I've got three lots of X's and you can't do that because it's going to always go back to this original X. So in this first question, I've got X1. Second one here, I'm going to go Y1. Now, if you just to sort of make a reference to the previous video, you can see I've got a curve like this. Now, if you're doing a transformation thing, in a say a SAC, you'd look at this and go, well, hang on, it's in this curve, okay? And it's in this curve, I might use a log y transformation or 1 over y or an x squared. We're doing the x squared now, but that's how you'd use it, okay? So, whoops, I'm going to go back to the calculator. All right, so that says nonlinear. We can't do it. You can't fit it as such at the moment. What can we do? Well, let's go back here and we're going to do the x squared. So I'm going to type in, it was x1, wasn't it? I'm going to go to variable. Oops. I'm going to go to x1. Oh, sorry, I should have done that. I'm going to type in. It wasn't playing very nice for me just then. X1, just using this calculator thing, can sometimes take a little bit of time, and I'm going to square it. Okay. All right. And then I go enter, and I'm going to go. I want it as a variable reference, and as you can see, I can look at all those values. And now, if I go back to this one here and change that to where was it? X squared, it becomes a fair bit more linear. And this is where we go menu, analyze, regression, a plus bx, and I get my equation. 2 plus 1 times x, okay? And as you go through here, blah, 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 because I've done all that, this is the equation I just got, okay? Now, remember, in the calculator, it says x, but you've made it x squared. So when you write your equation, you'll get your equation from the calculator here, y equals 2 plus, I'll just put it here like that as x. But because this is the transformed, okay, I have to write that as 2 plus x squared, okay? Now, the question then said, when x is 5, well, x is 5, I'm going to say y equals 2 plus, well, my 5 is there, it becomes 5 squared, and so therefore it equals 27. That's how you can make your predictions from this and how it relates back to that sort of graph you would have got there where you wouldn't have been able to make that prediction using a linear regression. You need to convert it. That's how we can use that. But you've got to remember this bit here. You have to change whatever the part you've transformed. Now, just before I move on to the next one, I want to quickly show you something. What I wrote here, x sq, I'm saying it's x squared, because if I put something here and put y squared, for example, let's do a quick one here. So I'm going to go y sq. This is what I'm saying. You can do multiple things. SQ, and this is where need to make sure it's equal. That's why it was playing up on me before. And I'm going to go y1. And I'm picking that as the reference because that's the one I want it to do. And then I'm going to square that, and I go enter. So as you can see, it's now looking at the y, and I've got the y squared. It's doing it. So I can have x squared, y squared, 1 over y right across this part here. Okay? You do as many as you need to do for that. Let's go to the next one. This is y2, x2, y2. So this is where I'm looking at doing it as a log. Okay? All right, so as you go through here, it says you've got your data in there. Let's quickly graph that. And we're going to go Control I, add data and stats. I want to make that x2, that y2, and you'll see it's got that shape to it. So if you remember going back to the summary quickly, it's got that shape. And so you could do one of these transformations. We're picking that one. Okay, let's quickly go on. I've done that. Now I'm going to do this part here. All right. And so let's go back to this. I'm going to go here. I'm going to go log. And by definition, it just goes log base 10. It makes the assumption it's going to be log base 10. Now, I can type x1, then I'll ask for a variable reference. I'm just going to go variable, and then I'm going to go x2, and then I'm going to go enter. All right. It gives you your data already worked out for you. I go back here, and I'm going to change that to, notice I called it log x, and again, it becomes a lot more linear. I go menu, analyze regression, showing it, and here's my equation here. Now, that's basically 0.11 plus 9.9x. Now, let's go down to here because it has got the 0.1992 log x. Now, remember, just make that connection. This is what it says here, but notice it's been changed to log x. You have to change this x into log x, because when it asks you to work something out, I have to put log 800 there. Okay, and here's calculation of the reciprocal. Okay, same, it's going to be the same, basically the same process. So let's get this up. That's here. I'm going to go again. It's an x value for this one. Let's go in, and it's just going to be 1 divided by, and this time it is x3 because it's the third one we're looking at. And I'm going to go enter, and it converts that. Oh, hang on, I haven't actually done the graph yet. So let's actually graph it first. So my apologies. Add data and stats. That's going to be x3. That's going to be y3. And you can see that that is a shape that's not linear. So again, if we went somewhere here, these are our options. We'd need to do all 4, but we're only doing this one. We might do another quick one to show what I mean. You can have multiple on the thing, but we'll work it out first. So you do all that. Now I've already done, if you remember, I've done the reciprocal over here. So let's just plot that now. And I called that recip, as in reciprocal of x. You can call it what you want. And that didn't do anything there, did it? Oh, because that was not a very smart move on my part, because that is y3. I need x, reciprocal of x. Oops. I was wondering why it wasn't working there. Now I've got a straight line. Now I can go menu, analyze regression, show linear, bang, I've got my equation. That means this here means 5 times 10 to the negative 14. Let's go back to the worked example here. Okay. So as you can see, 5, so it's a really, really small value of 5. of a number, as it says here. Notice, so we can rewrite the equation as y equals. So we can ignore this just saying that. Okay. Yeah, it's just because that means basically just to sort of, so if you have something like that, it's what they're doing there, just so you know, it means 0, 0. That's 2 zeros, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's close enough to equal to 0. So we've sort of essentially crossed that out for our purposes, and it's 30x, but remember, I've got to make sure that converts to the transformation I've done, and that transformation is reciprocal, because remember that means 30 over x, which is the same as saying 30 on 1 times 1 on x, and that's our transformation we did before. Okay, now just as a quick go through here, remember, see that last one had quite a few transformations we would have to do if we're doing this in a thing. So let's do a quick, let's call that, I'm just going to call it LX because takes too long to type on here. That's log x. I'm going to type in log x, log, then we're going to get bracket. Okay, and then we're going to go x3, so we're going to go variable x3, enter, done for that one. The next one was 1 over y, so then we'll do recip y, and I'm going to go 1 divided by, again, I want my y3, bang, and then the last one was log of y. Okay, I'm going to again call it ly just for log y for my purposes here, y. And yes, I actually do take quite a long time to find it on this little thing here. Log, they're going to go brackets. I'm looking for my variable y3, and I'm going enter, and bang, I've got all 4 transformations done in fairly quick amount of time. So if I want to graph each of those as you go here, well, it was in this one we sorted, it was, there was a log y, ly. Hang on, I've got to find it first. That was ly. Bang, I can see, oh, that's probably not going to be it. We do this more in the activity, but you can see not such a good fit, and that's going to change, and you get different R values and stuff. Again, now if I want to do a y, I'd convert that back to x3, and then I would change the y, and I'd go say log y. Okay, or it was recip y, and I could see, look, that's a pretty good fit too. Okay, and that's how you can get all your equations that quickly. Once you've put them all in, you can go, right, done all those, here's each equation, each time I've done a change, bang, put that down. That's what we use in the activity. Okay, thank you, bye.